Welcome to the AI Paper Podcast. We're your source for digging into the latest AI and tech research and, making sense of it all. Today we've got a really fascinating paper from Meta. It's called Meta CLIP 2, a worldwide scaling recipe. Sounds intriguing, right? All right, so for anyone short on time, here's the 1-minute rundown. This paper introduces Meta CLIP 2. It's essentially a new blueprint, a recipe for training CLIP models that's contrastive language image pre-training from scratch. And the key thing, they're using worldwide web-scale image text data. Now, the big challenge they tackled, well, there were two really. Scaling CLP beyond English has always been tricky because one, there weren't great ways to curate non-English data reliably, and two, there's this thing called the curse of multilinguality, where adding non-English data actually lowers the model's performance on English tasks. Weird, huh? So Meta CLIP 2 is actually the first system to really crack both of these problems. How? Well, it boils down to three things. Smart metadata design, a really scalable curation algorithm, and a robust training setup. They didn't just break that curse. They showed that English and non-English data can actually help each other out, the results. Pretty impressive. Their VITH14 model beat its English-only version by 0.8% on ImageNet zero-shot classification, and it outperformed previous multilingual models like MCLIP by 0.7%. Plus, it set new records on multilingual benchmarks, think CVQA, Babel ImageNet, XM3600. And get this, they did it without resorting to things like machine translation or totally changing the model architecture. Why should you care? Well, this is kind of a big deal. It opens the door for AI models that are genuinely global, more culturally aware, less biased, especially important as, English data on the internet isn't infinite. Okay, that's the quick version. Now let's really dive in. You've probably heard about CLIP models. They're everywhere now, right? Yeah. Foundational for computer vision, multimodal AI. They're used for zero-shot classification, image retrieval, even as the vision part of those big multimodal large language models, or MLMs. But taking them truly global, that's been the sticking point. So we're going to unpack exactly how Meta CLIP 2 tackles this and why their specific recipe is, well, pretty innovative for anyone dealing with massive amounts of multimodal data.
Yeah, it's really worth understanding why this global scaling was such a hurdle for so long. I mean, CLIP's success is undeniable, but like you said, it was almost entirely built on English image-text pairs. Billions of them, sure, but still just English. And that inherently limits things, doesn't it? The world speaks so many other languages.
It seems obvious now you say it. So if everyone knew the potential was there, what were the actual roadblocks stopping people from using all that non-English web content?
Well, you'd think it'd be straightforward, but it really came down to two major barriers. The first one was data curation. It's a huge piece of the puzzle. For English, the original Meta CLIP already had this pretty sophisticated and scalable method. It was good at finding lots of data and making sure to include those less common long-tail concepts, but a similar, robust way to curate non-English data, it just didn't exist. People tried things, of course, using external filters, often black boxes, or machine translating captions, or relying on private data sets.
So stuff that either introduces weird biases you can't track or just doesn't scale up properly, right?
Exactly. And think about the scale you mentioned. Over half the web content isn't in English. Previous methods basically just threw all that potentially valuable information away. A massive missed opportunity.
50%. That's, wow. Okay, so data curation was hurdle number one. What was the second big problem?
The second one is this phenomenon known as the curse of multilinguality. And it's not just a CLIP thing. We see it in large language models too. The basic idea is when you try to train a single model on lots of different languages, its performance on specific languages, especially English in many cases, often gets worse compared to a model trained only on English data.
Wait, so adding more data, more languages actually makes it perform worse on the original language. That feels completely counterintuitive.
It does, doesn't it? But it happens. The paper even cites an example. MCLIP, which was a multilingual CLIP model, performed 1.5% worse on the ImageNet benchmark than CLIP, its English-only sibling. So researchers were stuck in this dilemma. Do you optimize for English performance, or do you go for broad multilingual ability? Getting both at the same time seemed impossible with the old methods.
Okay, so Meta CLIP 2 isn't just a minor update then. It sounds like they've developed a whole new recipe, as they call it, for building these models from the ground up, using native worldwide data. What makes their approach so principled, especially since they deliberately avoided things like translation or private data?
That's a great question. Their core goal was generalizability. They wanted their findings to be broadly applicable, not just a one-off trick.
Yeah.
So they intentionally stuck very close to the standard OpenAI CLIP architecture. They only made changes where absolutely necessary to solve these specific worldwide scaling problems and makes their results much more foundational. And they built this whole recipe around three key pillars.
3 pillars. Okay, I like a clear structure. Let's break them down. Pillar number 1, worldwide metadata. How did they manage to expand the metadata globally?
Right, so remember, the original MetaCLIP relied on high-quality English metadata from sources like WordNet and Wikipedia concepts. For MetaCLIP 2, they basically took that idea and blew it up to a global scale. They extended it to cover over 300 languages. They pulled data from 4 main, high-quality, human expert curated sources. There's Multilingual WordNet covering 31 languages, then Wikipedia Unigrams and Bigrams from dumps across 329 languages, and they had to use special tokenizers for languages like Japanese or Chinese, the ones written without spaces between words.
Ah, the Scriptio continual languages.
Right, exactly. And finally, they use Wikipedia titles, sampled randomly over time, and ranked by click-throughs to get a sense of real-world importance.
That's some serious data wrangling. But I guess you can't just lump all those languages together in the metadata, can you? You mentioned the word mit, meaning different things in English and German. How'd they handle that?
That's a really critical design decision they made. They decided to maintain independent metadata for each language. That makes intuitive sense, right? Because words, even if they look the same, can have totally different meanings or nuances in different languages. This independent approach didn't just perform better, it also gives them a lot more flexibility for the future, for refining things language by language.
Yeah, that seems crucial for actually capturing genuine linguistic diversity. Okay, Pillar 1 is the expanded language-specific metadata. What's Pillar 2? The worldwide curation algorithm. This sounds like where the magic really happens, especially with balancing concepts across languages.
It really is ingenious. So the algorithm starts by identifying the language of the alt text for each image that's LID, language identification.
Sure.
This lets it pick the right language-specific metadata for matching concepts within the text.
Makes sense. Get the language right first, and then this concept balancing, that twang thing. English Meta CLIP aim for about 6% tail concepts. Did they just apply that 6% rule everywhere?
That's where they got clever. They kept the idea of that 6% tail concept ratio from the English version that's invariance assumption. But instead of one single threshold, P, for all languages, they calculated a unique language-specific threshold, clang, for each language individually.
Ah, okay. Why was that necessary?
Because the amount of data available and the natural distribution of common versus rare concepts varies hugely from language to language. If you use just one global threshold, you'd risk messing up the balance. For languages with less data, you might end up overrepresenting common concepts and washing out the rarer, but still important, tail concepts. Clang prevents that.
So it's like a tailored balancing act for every single language, ensuring you get a good mix of common and rare ideas, no matter how much data you have for that language.
Smart. Can you walk us through the steps? How does the algorithm actually do this? Sure. It happens in 3 main stages. First, it does that language-specific substring matching using the right metadata, and then it adds up the global counts for every concept across all languages. Second, it calculates the unique slang threshold for each language, aiming to match the English tail proportion target. And third, it samples the actual image text pairs. Pairs identified as tail concepts get sampled with 100% probability. You definitely want those. Pairs identified as head concepts get downsampled based on that language's specific lang.
And I bet doing this efficiently across billions of pairs is non-trivial.
Oh, absolutely. They mention using highly optimized algorithms like Aho-Karasik for the string matching apparently 2,000 times faster, plus techniques like lazy loading for metadata and memory mapped files for the sampling probabilities, essentially for working at this scale.
Incredible technical detail there. Okay, so we have worldwide metadata and a smart algorithm to curate balanced data from it. But you said earlier, even with perfect data, that curse of multilinguality can still bite you. So Pillar 3, the worldwide training framework, must tackle that directly.
Precisely. This is the final piece needed to really conquer that curse. They made 3 key adjustments to the standard CLIP training process. First, obvious one perhaps, they swapped out the English-only text tokenizer for a proper multilingual one. They tested a few and found that the XLMV tokenizer, which has a massive vocabulary of 900,000 tokens, gave the best results across the board.
Okay, multilingual tokenizer makes sense. And you mentioned scaling the scene training pairs. That sounds like the direct counterattack against the curse hurting English performance. How did that work?
Yeah, that's fundamental. Think about it. If you just add a ton of non-English data, but keep the total training steps or batch size the same, the amount of English data the model sees effectively gets reduced, right? It gets diluted.
Right, which would naturally hurt English scores.
Exactly. So to prevent that and actually boost English performance while also learning from the new data, They significantly increased the global training batch size by a factor of 2.3. This increase reflects the fact that English data still makes up a large chunk, about 44%, of their final training mix. A bigger batch size allows for more effective cross-lingual learning signals without starving the model of English examples.
So more data, bigger batches. Did this imply they also needed beefier models? Was there a certain model size required to actually handle all this complexity and break the curse?
That's a really crucial finding they reported. They looked into this, what's the minimum viable model capacity? And they found that even a pretty large model, the VITL-14 from OpenAI, still showed signs of the curse. Its capacity just wasn't quite enough to fully benefit from all the multilingual data. It was only when they scaled up further to the VITH-14 model that they saw the breakthrough. That size seemed to be the inflection point where the curse was finally broken, and they started seeing strong gains in both English and non-English performance simultaneously.
Wow, so it's not just about the data or the training recipe, but also having a model architecture that's big enough to integrate it all effectively really shows how interconnected everything is.
Definitely. Scaling the data needs corresponding scaling in model capacity to really pay off.
Okay, let's talk results then, because it sounds like they actually achieved that mutual benefit, breaking the curse and having languages help each other. Did it work out?
It absolutely did. This is the core takeaway. Meta CLIP2, especially with that VITH-14 model and the scaled training, successfully shattered the curse of multilinguality. Get this. On ImageNet Zero Shot, the English accuracy didn't just stay the same. It increased from 80.5% to 81.3%. It actually beat its English-only trained equivalent.
So adding all those other languages helped English performance.
Exactly. That proves the mutual benefits idea. Non-English data is helping the English side, and presumably vice versa, which, as you pointed out earlier, is super important as easily accessible English web data starts to plateau.
That's fantastic. What about the specifically multilingual benchmarks? Did it set new records there too?
Oh yes, the gains are pretty dramatic. On CVQA, they hit 57.4%, which blows past MCLIP scores. On Babel ImageNet, they reached 50.2%, again significantly better than MCLIP's 40.2%. And for image-to-text retrieval on XM3600, they achieved 64.3% compared to MCLIP's 56.6%. They also noted improvements on other benchmarks like Flickr 30K and XTD.
And these are big jumps, achieved without any weird tricks.
That's what makes it so impressive. Minimal changes to the basic CLIP model. They actually used fewer total training pairs than the CLIP series did, a lower image resolution than MCLIP used. And again, no private data, no machine translation shortcuts, no knowledge distillation, just the core recipe.
Okay, the numbers are great, but stepping back, what are the broader implications here? This feels bigger than just improving benchmark scores. What are the sort of desirable side effects of scaling this way?
You're right, it's much more fundamental. There are several key benefits that emerge naturally from their approach. First, full multilingual support. Their pipeline is designed not to filter out data based on language. If it's there, it can be used. Second, native language supervision. The model learns from alt text written by native speakers in their own language. This avoids the biases and potential inaccuracies that creep in when you rely on machine translation.
That seems huge for cultural relevance.
Absolutely, which leads to the third point, cultural diversity. Because they keep the global image distribution, the model gets inherently better at understanding geographical context, recognizing region-specific things. They showed this on benchmarks like Dollar Street and GeoDA. The worldwide data improved performance significantly. Fourth, there's the no-filter philosophy. By removing that last big filter, the English-only constraint, they minimize a major source of potential bias in the data pipeline.
And finally,
this work provides a massive, globally representative image-text dataset foundation. It's not just useful for training better CLIP models, but it benefits any research that builds on CLIP data. Think MLLMs, self-supervised learning, even image generation models like daily or diffusion models. It lifts the whole ecosystem.
it really sounds like a foundational contribution then, creating a better base layer for so much other AI work. One last technical bit, how were the actual embeddings good quality?
Yes, they checked that too. They look at alignment, how well the image and text embeddings match, and uniformity, how well the embeddings fill the space. On their holdout data, Meta CLIP2 scored really well on both. Good alignment means the text is relevant to the image in the embedding space. Good uniformity means the representations are distinct and spread out. Both suggest high-quality, useful embeddings, which underpins the strong performance on all those tasks.
Okay, let's wrap up this deep dive. We've seen Meta CLIP 2 emerge as really the first complete recipe for training CLIP models from scratch, using genuine worldwide image text data. They tackled those two massive hurdles, multilingual data curation and that pesky curse of multilinguality. And crucially, they show that English and non-English data aren't enemies. They can actually boost each other, setting new state-of-the-art results along the way.
And the fact that they've open sourced the metadata, the curation code, the training code, that's huge for the community. It really lowers the barrier for others to build on this. So the final thought to leave you with is, what does this really unlock? Think about the potential breakthroughs when our foundational AI models truly start reflecting the rich diversity of human language, culture, and experience from across the entire web, not just the English-speaking part. What kinds of new applications could emerge from models that have a more inherent understanding of global nuances, different cultural concepts? It really highlights the power of scaling AI, not just bigger, but smarter, more inclusively, and intentionally breaking down these linguistic walls.